Hello everyone and welcome to Minute Maths. Today we're going to be talking about something which I really enjoy learning about. It's called the Fibonacci sequence, and you see the Fibonacci sequence a lot in nature. So first, let me explain what the Fibonacci sequence is. If you look at this sequence, you can notice a few things. First of all, each number is equal to the sum of the two previous numbers. So for example, let's take 3. 3 is equal to 1 plus 2. And you can look at any of these numbers such as 5. 5 is equal to 2 plus 3. Now, something else which is interesting about this specific sequence is if you take each of these numbers and you figure out the additives to this, you get plus 0, which you can ignore, plus 1, plus 1, plus 2. Now, this sequence looks an awful lot like this sequence, which is something interesting, and this would continue all the way. So, if you had, say, 8, then 13, it would be plus 1, plus 1, plus 2, plus 3, plus 5. Now, we can look into the geometry of this. So, if you draw the sequence in squares, you can see square 1, another 1, 2, 3, 5, 8, and the closer that you get to the ratios of these rectangles is the closer which you get to this specific number. This is the golden ratio. The golden ratio you see in many aspects of the world. You see it a lot in nature and in architecture, dating back to ancient Greece, where the Parthenon had this specific ratio. I'll go over what this ratio is later, but right now you can know that the golden ratio is the ratio of each side of this rectangle. For example, in seashells, you have this, where it is 1, 1, 2, 3, and so on and so on and so on until you have this beautiful spiral shape which you see in nature. Let's go on to probably one of the most famous examples of the Fibonacci sequence, which is the rabbit problem. Now the rabbit problem states that you have one rabbit and that every 1 month it makes one baby rabbit. So let's say you start off with one baby rabbit. Alright, so after the next month, you'll have one adult rabbit. And then the next month, that adult rabbit will have a baby rabbit. And then the next month, this adult rabbit will have a baby rabbit, and this rabbit will grow. So you will now have 2 adult rabbits and 1 baby rabbit. Now, the next month is where it gets more interesting. They've just been increasing by 1 so far, but this year, both these rabbits have baby rabbits, and this rabbit grows up. So you now have 3 adult rabbits and 2 baby rabbits. Now, if you look at the total of this, you have 1, 1, 2, 3, and 5. Now this looks very familiar, isn't it? It's the Fibonacci sequence, and we can keep on going on this. The next month, you'd have 5 adult rabbits, because these would grow up and these would stay the same, and then 3 baby rabbits, because these rabbits would have babies. And you can also see from this something very interesting. The amount of baby rabbits goes here. 1, well, you can ignore the first one because that's just like the starting rabbit. So you have 1, 2, 3. Same with adult rabbits. You have 1, 2, 3, 5. So in this specific problem, there's a lot of Fibonacci sequence. Do something interesting with the Fibonacci sequence. So let's say you have some terms. So we'll put them as f. So you're going to have f1 as the first sequence of the Fibonacci sequence, and then f2, and so on and so on and so on. So let's say you have fn, so meaning any number, we can call it anything you want to, and fn plus 1. So, oh, and also fn minus 1. So, let's say we did fn plus 1, meaning a number the next number in this Fibonacci sequence, minus fn. What do you think the answer is going to be? What do you think the answer is? And you don't have to solve for n here. It's just asking the question, what is this going to be equal to? Try to put your answers in the comments if you figure this out, and I'll look to see if anyone got it correct. Okay, so there are 2 ways in which you can figure out problems with the Fibonacci sequence. So there's 2 types of problems which you're going to be getting around the Fibonacci sequence. There's figure out what this pattern is, and finish this pattern. And sometimes you might get both of those problems. So let's go over the first problem first. So they'll say, use the Fibonacci sequence and figure out what the next 3 terms are going to be. So let's say the Fibonacci sequence was 3, 3, 6, or let's make it more interesting. 3, -8, -5, -13, dot, dot. So you have to figure this out. So you know that this is the Fibonacci sequence because they tell you, but how would you keep on going? So you would start by saying, what is this number going to be equal to? And since the Fibonacci sequence, you know that it's the next term is equal to the first term minus the next term. So you have this term, you know you get it by adding this one and this one. So you'd add them together and you get -18. And then you just continue. -13 minus 18 is equal to -31. And then you do the same thing to get -49, and then your question's done. Now, there are sometimes more questions such as this. So they'll give you this sequence. This one can just be easily memorized. They'll give you this sequence, or maybe a different type of sequence. Maybe it'll be 3, 8, 11, ... And they'll ask you, what type of sequence is this? And both of these answers are the Fibonacci sequence. And you can tell, since each of these numbers is equal to the sum of the 2 previous numbers. Well, this would probably require more information. So let's say it gave you 19 and 30. You would say, okay, well, 11 is equal to 3 plus 8, 19 is equal to 8 plus 11, and 30 is equal to 11 plus 19. So, you know that this is the Fibonacci sequence, and you'd be able to answer, yes, this is Fibonacci sequence. Great, so I promise this is going to be the last thing about the Fibonacci sequence. we're going to just be going over the regular Fibonacci sequence and all the numbers up to, let's say, 100. So, you're going to start off with 1, then 1, then 2, then 3, 5, 8, 13, 21, 34, 55, and 89. And these are all of the numbers. Thank you for watching this video. I really appreciate it. This is my first video. If you'd like to see more minute maths or different topic, anything, suggestions, please just feel free to put them in the comments. Please like, subscribe, share, and thanks for watching this video. I'll see you in the next one.